Good morning, everyone. My name is Prabhav Dobhal. I am in section A, group 2. My university roll number is 2018991 and my class roll number is 43. Today I am presenting a PPT on basics of big data. So let's start. Now, the first thing which comes to our mind while uh, knowing about big data is what is big data? So, big data is basically a collection of data that is huge in volume, yet it's growing exponentially with time. It is basically data with so large size and complexity that none of the traditional data management tools can store it or process it efficiently. Uh, Big data is also a data, but it's just a data with huge size. As I've written, big data is an evolving term that describes any voluminous amount of structured, semi-structured, and unstructured data that has the potential to be mined for information. Now, what is semi-structured, unstructured data? We are going to study later in the presentation. So let's just start. Now, why big data? Why do we even require big data? Or a better question could be why big data is important. So big data is important because companies use big data in their system to improve operations, provide better customer service, create personalized marketing campaigns, and take other actions that ultimately can increase revenue and profits. Basically, the businesses that use it effectively holds a potential um, competitive advantage over those who don't use it because they are able to make faster and more informed business decisions. Let's let me tell you an example. For example, if big data provides valuable insights into customers that companies can use to refine their marketing, advertising, and promotions in order to increase customer engagement and conversion rates, then both historical and real-time data can be analyzed to assess the evolving preferences of consumers or corporate buyers, enabling businesses to become more responsive to customer what they want and need. We can easily target them. uh, I mean, the exact thing that they want, we can just target them that thing, and it is going to be just with pinpoint accuracy we can uh, easily sell what we want to sell to the perfect audience. Now, people are using social media, which is also an example of big data. A large amount of information is stored in social media, and it is stored in form of big data. All major companies are turning towards big data to make strategies to understand their consumer better and to increase their revenue and reduce cost. So basically, yeah, the big data is very important to uh, point pinpoint accuracy target the required audience. Now, the as I've given some examples of top big data applications, it can be used in education, government, healthcare, weather patterns, banking, agriculture, fast food, airline, e-commerce. So we can see that it's globally connected. Almost every sector requires big data. Now, there are five V's of big data. The first one is volume, the second one is velocity, the third one is variety, the fourth one is veracity, and the fifth one is value. Now, let's study about all of these. Now, the first one is volume. Volume, it is the first V of the big data. It refers to the amount of data that exists. It's basically the volume. Volume is like the base of big data, as it is the initial size and amount of data that is collected. If the volume of data is large enough, it can be considered big data. What is considered to be big data is relative, though, and it will change depending on the available computing power that's on the market. As I have written, the name big data itself is related to a size which is enormous. Volume is huge. Volume is a huge amount of data. To determine the value of data, size of data plays a very crucial role. If the volume of data is very large, then it is actually considered as big data, as I have said earlier. This means whether a particular data can actually be considered as a big data or not is dependent upon the volume of data. Hence, while dealing with the big data, it is necessary to consider a characteristic volume. Example, I've also given an example. In the year 2016, the estimated global mobile traffic was 6.2 exabytes, which is 6.2 billion GB. It's a very, very enormous amount of data, and per month, and that also per month. Also, by the year 2020, we will have almost 40,000 exabytes of data. So we can just see how enormous the data is. Now the second V is velocity. Velocity refers to the high speed of accumulation of data. Uh, so basically, it refers to how quickly data is generated and how quickly that data moves. This is an important aspect for companies that need their data to flow quickly. So it's available at the right times to make the best business decisions possible. And uh, in big data, velocity data flows in from sources like machines, networks, social media, mobile phones, etc. There is a massive and continuous flow of data, as I've said. This determines the potential of the data, of how fast the data is generated and processed to meet the demands, which I've said earlier. Sampling data can help in dealing with the issues like velocity. Example, there are more than 3.5 billion searches per day are made on Google. Also, Facebook users are increasing by 22% approx year by year. Now, let's say an organization that uses big data will have a large and continuous flow of data that is created and sent to its end destination. Data could flow from sources such as machines, um, uh, networks, smartphones, or social media. This data needs to be quickly digested and analyzed quickly, and sometimes in near real time. Let me give an example, my personal example. Uh, in healthcare, there are many medical devices made today to monitor patients and collect data. From in hospital medical equipment to wearable devices collected, data needs to be sent to its destination and analyzed very quickly, because in hospital uh, you cannot tell the patient to wait very for a very long time, because there are emergencies in case of when you are about to save a life. Now let's proceed to the next V, which is veracity. Now it refers to inconsistencies and uncertainty in data. That is, data is which is available can sometimes get messy, and quality and accuracy are difficult to control. um, we can also say like the gathered data could have missing pieces, maybe inaccurate, or may not be able to provide real valuable insight. Big data is also variable because of the multitude of data dimensions resulting from multiple disparate data types and sources. Example, data in bulk could create confusion, whereas less amount of data could convey half or incomplete information. So basically, veracity overall refers to the level of trust there is in the collected data. The data which is provided should not be broken, or shouldn't have missing pieces. It should be proper. Data can sometimes become messy and difficult to use. A large amount of data can cause more confusion than insights if it's incomplete. For example, concerning the medical field, if data about what drugs a patient is taking is incomplete, then the patient's life may be endangered. So we can see it's very important to have veracity in data. Now, let's proceed to the next V, which is value. Uh, After having the three V's into account, there comes one more V, which stands for value. The bulk of data having no value is of no good to the company unless you turn it into something useful. Data in itself is of no use or importance, but it needs to be converted into something valuable to extract information. Hence, you can state that value is the most important V of all the five V's. Now, what it means is that it refers to the value. It refers to the value that big data can provide, and it relates directly to what organizations can do with that collected data. By being able to pull value from big data is a requirement, as the value of big data increases significantly depending on the insights that can be gained from them. Uh, Organizations can use the same data tools together and analyze the data, but how they actually derive value from that data should be unique to them. That's what actually is all about value. Now let's move on to the next V, which is variety. It refers to the nature of data that is structured, semi-structured, and unstructured. As I promised, I'm going to discuss these later in the video. It also refers to the heterogeneous sources. Uh, Variety is basically the arrival of data from new sources that are both inside and outside of an enterprise. Now, this variety actually refers to the diversity of data types. An organization might obtain data from a number of different data sources, which may vary in value. Data can come from sources in and outside an enterprise as well. The challenge in variety concerns the standardization and distribution of all the data being collected. And this collected data can be unstructured, semi-structured, as I have said, which I'm going to discuss later, the meaning of these. But as a mark, I'm just want to clarify that these collected data can be unstructured, semi-structured, or structured in nature. Unstructured data is data that is unorganized and comes in different files or formats. Typically, unstructured data is not good fit for a mainstream relational database because it doesn't fit into conventional data models. Whereas if we talk about the semi-structured data, it is the data that has not been organized into a specified specialized repository but has associated information such as metadata. This makes it easier to process than this makes it easier to process than unstructured data. Structured data, meanwhile, is data that has been organized into a formatted repository. This means that the data which is made more addressable for effective data processing and analytics. Okay, now let's move to the the types of data. So there are three types of data. The first one is structured, second one is unstructured, and the third one is semi-structured. Now, structured data. So any data that can be stored, accessed, and processed in the form of fixed format is termed as structured data. Over the period of time, talent in computer science has achieved greater success in developing techniques for working with such kind of data, where the format is well known in advance and also deriving value out of it. However, nowadays we are facing issues when a size of such data occurs. So let me give you an example of structured data. We can see that here it, it is well structured that there is a person named Monica. Her age is 33 and her position is a life coach. And we can see that, so for example, Tina is a person, I mean, there is a person whose name is Tina. Uh, her age is 22 and she is a doctor. So the information is organized. We know that there is a person named Tina. We know her age and her position. We know the things in a structured order. Now, the unstructured data. Any data with unknown form of or the structure is classified as unstructured data. In addition to the size being huge, unstructured data possesses multiple challenges in terms of its processing for deriving value out of it. A typical example of unstructured data is a heterogeneous data source. Heterogeneous data source basically means the dissimilar types of data which are combined together. uh, for example, I've written containing a combination of simple text files, images, videos. Now, they are unstructured because they are of different extensions. One is text file, image, and another one is image, and another one is video. Nowadays, organizations have wealth of data available with them, but unfortunately, they don't know how to derive value out of it since this data is in its raw form or unstructured form. Now, as I've shown here, customer reviews, images, handwritten documents, tweets, audios, videos, emails. Now, they are randomly placed here, which do not even interlink with each other. They are of different formats. We don't have a proper structure about them, that how they are linked or what they actually mean. I mean, there is no linkage or anything, no proper structure basically. They're just randomly placed. Now let's come on to semi-structured data. Semi-structured data is a type of structured data that does not hold to the tabular structure of data models associated with relational databases or other types of data tables, but still includes tags or other markers to separate semantic elements and enforce hierarchies of records and fields within the data. As a result, it is also referred to as a self-describing structure. Now, in self-structured data, entities of the same class may have different characteristics despite being grouped next to each other, and the order of the attribute is unimportant. So this is it. Thank you for listening to my presentation. I hope you have a great day.